Assalamualaikum and a very good day. So in this video we are going to look at Miller indices. So for Miller indices is used to label the plane and direction of atom in a crystal. It means that we will learn two types of Miller indices. The first one is on direction, and on the next video we will look at on Miller indices on plane. So before we begin our class on Miller indices, we first need to know about coordinates in crystal structure. Right. So we look at this coordinate for point 5. The coordinate for point 5 will be half in x direction, half, half in y direction, and in z direction it also move half. Right. Okay. So the coordinate that we get is half, half, and half. Okay. So now let's take a look at all the points here that we have. We have point 1, point 2, point 3 until point 9. Okay. For point 1, the coordinate is over here. So over there the coordinate for x-axis is 0, for y-axis is 0, and z-axis is 0. So the point coordinate will be 0, 0, 0. Now we look at coordinate at point 9. Okay, so for the point 9 we have coordinate of x is 0. You can see it's not moving from x in x direction. Y-axis it move 1, let's move 1. Okay, and then in z direction it also move 1. So the coordinate for point 9 will be 0, 1, 1. Okay, I hope you understand that. Now we are going to look at Miller indices of a direction. How to determine crystal direction indices? Okay, the first step is determine the length of the vector projection on each of the three axes based on x2, y2, z2 minus x1, y1, z1. The second step is these three numbers are expressed as the smallest integers and negative quantities are indicated with an overbar. I will explain about it in the example. And then the last one, label the direction as HKL. You must know the enclosed for Miller indices of direction is like this. Okay. Before we begin, I brief a little bit on the step that we are going to do. The first one, we must write the axis. We have x, y, and z axis. And then we find the coordinate for the head, x for head, y for head, and z for head. And then we find the coordinate for tail, x1, y1, and also z1. And then we use head minus tail like this, and then we need to make a reduction if necessary. We are making reduction when we have a fraction over here. For example, after head minus tail we get 1 over 2, and then we must turn the fraction into an integer, right? For the last step, we do the enclose using this symbol. Okay, right. So for further, I will show you in the example. Now we are going to look at example for crystal direction indices. Before this, I told you guys about head and tail. what is meant was the head have an arrow like this, and then the tail have no arrow. For the first example, to find the Miller indices of direction for this crystal, what we have to do is we write down axis. We have x, y, and z axis, and then we need to find the head. After that, tail, head minus tail, reduction if necessary, and last thing, and close. Then we take a look for the coordinate of the head over here. The coordinate is 1 for x direction, 1 for y direction, and 0, it doesn't go up, so 0 for z direction. So we write here for the head, x is 1, y is 1, and z is 0. After that, we do for tail, the coordinate is 0, 0, 0. It doesn't move anywhere, any direction. Okay, so the tail is 0, 0, 0. For head minus tail, 1 minus 0 is 1, 1 minus 0, 1, and then z is 0. The last part, we do the enclose, 1, 1, 0. Please remember, the enclose must be this shape. We try with another example. Over here, for the second crystal direction indices. For second example, it is the same step as the first one. For second example, the location of the head is over here. We can see that the head is moving 1 from x direction, 0 in y direction, and 0 in z direction. So 1, 0, 0. And then for tail, it moves 0 in x direction, 1 in y direction, and 0 in z direction. So 0, 1, 0. So for the projection, 1, 0 minus 1 is negative 1, and 0. So as for the enclose, we write down 1. For the negative value, we must write down 1 bar and 0. Please remember, for the negative value, we must write down bar, over bar on top of the number. For the third example, we have a fraction as a coordinate. So we need to do reduction for this case. Okay, as usual, for the first step, we write down the coordinate of the head. Over here, we have 0 in x direction, and then we have 1 in y direction, and we have 1 over 3 in z direction. For the tail, the coordinate is 0, 0, 0. So 0, When we have a fraction, we need to do reduction to make it an integer like this. How to make this an integer? We need to times all of it with 3. 0 times 3, 1 times 3, and 1 over 3 times 3. So we will get 0, 3, and 1. Okay, 1 over 3 times 3. So for the enclosed, we will have 0, 3, 1. Okay, for example 3. Now the problem is we are given the Miller indices direction. We need to draw the following Miller indices of direction. We need to reverse from what we have done before. First step, we write down the axis. Now we try to do the first example. So the Miller indices of direction is 1, 0, 0. Okay, we reverse, we go to reduction. So we go to reduction. Okay, so for head minus tail will be the same because we don't have any number more than 1. When we have more than 1, we need to do reduction. Then for the tail, head minus tail will be 1, so we make the head is 1 and the tail is 0. Y is 0, so the head and tail 0, and then the Z is 0, 0. So the coordinate that we will get is like this. That's all for Miller indices of direction. You guys can try to do the rest. If you have problems, you guys can contact me. Thank you.